Hope everyone know the topics, right? Today, what topics we are covering, going to.
Yeah, it's hashicorp Terraform.
Yes. Anyone have prior experience in Terraform or the tool for which purpose we are using the tool Terraform? Any idea?
It's for creation of infrastructure. Usually we create an instance through manually in the AWS. In Terraform, we create automatically. There is no manual intention in creation of instance or infrastructure for everything. So in terms of handling Lambda or S3 or DB, everything that we are going to do it automatically in the Terraform.
Good. What about others? Amol?
No, I don't really know. I think I did have one auxiliary question though. A lot of times to get into an IT job, you have to have some portfolio of code or some experience you show. So because like some languages, you could maybe write some code and have a sample code to talk about in the interview. But because cloud is like an infrastructure thing, like how do you like show that you have do some real world project and have like some work experience you could put on your resume, right? Like to help you get an interview and do you know of any projects like that, or should you work with some Linux open source something or Kubernetes open source? A lot of open source things are there, right?
Yes.
For the mock project, contribute to something.
That I will check actually.
Oh, okay.
Regarding the project live experience or hands-on live project or anything like that.
Okay, thanks. Sorry to break. I don't really have any experience of Terraform.
Okay. So, Shilpa, same to you, right? I mean, not prior experience.
Yeah, no.
My screen is visible. All of you?
Not yet.
Didn't share, I think.
Yes, we can.
So coming to Terraform, okay, it's a open source infrastructure as a code tool developed by hashicorp, and we can define and provisioning data center infrastructure using high level configuration language. So what is high level configuration language?
It's a human readable language.
Right. So it's like a code, but we can easily know what are the things included in that code. Simply, as a human, we can read the code and knowing what are the infrastructure or what are the resources that inside the code. That's called human readable. Terraform support various cloud provider actually, like AWS. Terraform support AWS, Azure, GCP. So we can use Terraform in any cloud provider. Okay. Yeah, I'm audible, right?
Yes.
Yes.
So basically, Terraform is a automation tool to provision infrastructure. What is infrastructure means? For example, EC2. In AWS, we can say like EC2 is one of the infrastructure, storage is another infrastructure, different services are there, like Kubernetes, that is another infrastructure, uh, container service. There are a lot of services available in AWS, so we can automate the deployment, okay, using Terraform. So coming to the workflow, okay, consider this is a
You're
cloud
not
provider.
audible, Tawfiq, actually.
Yeah, audible. I'm audible, right?
Now
It
you
was
are.
breaking. It was
Now you're
breaking.
right.
Now it's stable.
Yes.
Okay. So consider this is any AWS, sorry, any cloud provider like AWS or Azure or GCP. These cloud providers have their own automation tool. Okay, like coming to AWS, AWS have cloud formation that is fully managed by AWS. So if we only concentrate on AWS cloud provider, okay, in our future in our career, then we can concentrate on cloud formation, because cloud formation is a tool for automating AWS resources instead of Terraform. Or else coming to Azure, then we can choose Azure Resource Manager. That is Azure's automation tool. Then coming to GCP, GCP have their own automation tool. I missed the name. So coming to each different provider, they have their own automation tool. But as a DevOps engineer or a cloud engineer, we can focus on Terraform, because this is an open source tool, and this Terraform tool we can integrate with any cloud provider. Even we can integrate with the other application. Like for example, we done one class on Datadog, right? So we can automate application deployment or anything. We can use the Terraform. So coming to Terraform, we can integrate this Terraform with any provider and any cloud-based application. So consider this is AWS, okay? This is our AWS account. And we have a local machine or the machine where we are working, okay? Consider this is our laptop. And where we installing this Terraform, we install the Terraform in our local machine. That is, in our laptop, we install Terraform. Then we will authenticate, or we will create a connection between our local machine to our corresponding cloud provider, Azure or AWS or GCP. Okay. So how we will connect? Using, we can using, if we are using AWS, then we can install AWS CLI. AWS CLI. It's a command line tool for AWS. And we can connect with our AWS account, okay, using command line. Only we will get the command line configuration, not the entire console management, okay. Only graphical way, sorry, command way we can connect with our AWS account. That's why we are using AWS CLI. So if we install AWS CLI and we successfully authenticate with our AWS account, then we didn't go to the AWS dashboard, I mean, AWS login page and provide the credential, then go to the dashboard. We don't do that. We only performing using the command line, okay. For example, if we need to install EC2, then we can use that by command line. So in this case, we only connect with our local machine to our AWS account using AWS CLI. After that, we will install Terraform in our local machine. Then we will write Terraform files. Terraform have different file. Okay, that file extension would be like, for example, the file name is main. Then the extension would be like that, tf.tf. Some other Terraform files look like providers. Provider.tf. Then resources.tf. These are Terraform files. We can easily know the extension tf. Okay. Then coming to life cycle, Terraform have different life cycle actually. Anyone know the life cycle? Terraform life cycle. One more thing I need to add here, like in simple way, first we need to install AWS CLI for authenticating our AWS account. If we have Azure, then what we'll do? We have Azure CLI there, so we need to install Azure CLI in our local machine. Then we need to install Terraform from. We can download it from official website of Terraform. Then successfully we installed Terraform in our local machine. Then we will write up the codes. Okay, that code inside file called this provider.tf or resource.tf or main.tf. As per the requirement, we need to choose corresponding file. Then we need to include all the codes inside the file. After that, we will push the code. Okay, these are the codes like resource.tf or provider.tf. We will push from our local machine to our cloud provider. This is a push model. Okay, Terraform is a push model, pushing the entire code from our local machine to cloud provider. So consider we have the code. Okay, in our local machine we have the code. The file. So using Terraform, we will push the file to here. AWS. So what are the things we included in the file that will execute in our cloud provider? Got it? Anyone have any doubt?
So is this like you do stuff like pull from GitHub or pull from Docker Hub? Is there like a Terraform, like a hub you can push and pull to?
Yes, it's like not entirely like that. Okay, for the Docker Hub, we build the image and we saved using the pushing our image to Docker Hub, right? Then we actually it's storing in Docker Hub. Then whenever we need, we will using Docker pull command to pulling the image to our local machine. This is similar, but we have the code here. We write up the code here and we sending the code from our local to cloud provider. Got it? Clarified, right? I'm all or confused.
So can you explain again what?
So this is our local machine, okay?
So you pushed it from your local machine with the help of Terraform.
Right. Terraform have different life cycles, okay? So one of the life cycle we are using for pushing the code to corresponding cloud provider. So what are things inside the code? that will execute here. For example, it will this code for provisioning an EC2 machine. Okay, so when the code comes here, it will create a EC2 machine. Got it?
So is Terraform like some kind of, it carries some kind of configuration information about which machine to pick in the cloud, and now deploy this code there, start this virtual machine, you know, like it's some instructions like that, like a script.
Yes. Then coming to life cycle, okay. Terraform have different life cycle. The first one is Terraform init. So coming to life cycle, okay, like yes, coming to life cycle, Terraform init is one of the command that we used for initializing the working directory containing the Terraform configuration file. So it will it will download the necessary provider plugins and prepare the backend for sorting the state. That means first we need to establish a working directory connectivity from our local machine to cloud provider when we using the first lifecycle Terraform init. So this is basically a command. After we configuring all the things, first we need to start the connectivity from our local machine to provider. Okay. So what will we do? We need to perform different commands like Terraform init. Then the next cycle is Terraform plan. So Terraform plan is another command to create a execution plan. Okay. Actually, it will create an execution plan and it compare the current state of the infrastructure with the desired state defined in the configuration file. So this step allows us to review the changes and like Terraform will make without actually apply them. So we can reviewing our entire entire resources to be before the apply command. Then the next stage is, next cycle is Terraform.
Can you re-explain that plan one again?
Terraform plan, it's a command. We create an execution plan. Actually, it will create a execution plan actually. For example, I need to create two EC2 machine, okay? So all the codes are in my local machine, right? So this plan execute a execution plan and we can compare the current state of our infrastructure with the desired state defined in the configuration. That means, for example, we already deployed some infrastructure using Terraform, okay? Consider we configure two machines in using Terraform. That is successfully done. Then after some time, we need to add more instances, okay? So what we'll do, again, we come to the existing Terraform file and add the changes, okay? So at that time, we again using this lifecycle called Terraform plan. So we can say, we can see and we can compare the current state of infrastructure and the desired state, or desired configuration by all the things using the Terraform plan command. When coming to lab, you will get more idea.
Why is init before plan then?
First, we need
Shouldn't you
to
have a plan
initialize,
then init?
yes, initializing
Terraform
working directory containing the Terraform
configuration
file.
Okay.
If we didn't have the configuration file, we failed the init state. That all thing I will show you when coming to the lab. Then coming to Terraform apply. Okay, Terraform apply. This will applies the changes. Okay, this command applies the changes to reach the desired state of configuration. It will create the update or delete resources as needed. We can review the plan before confirming the application. For example, whenever we using the Terraform apply command, our entire code pushing from our local machine to cloud provider, and it will create our resources. Then one of the life cycle called destroy, Terraform destroy. So using a single command, okay, like this init, plan, and apply, we can create even the data center like VPC, subnet, root table, all the things we can create, and we can create virtual machines, storage devices, or anything we can create using Terraform, okay, using the simple command like Terraform apply. Same way we can destroy entire infrastructure using Terraform destroy. So with a single command, we can destroy all our infrastructure. That's the last one, Terraform destroy.
Taushif, can we do changes after Terraform plan? If you do Terraform apply, can we do any changes if you want? So for example, we created some EC2 instance and S3 bucket, and we applied it, that one. We did a Terraform apply. And we have to do some changes on the EC2 instance. After apply, can we do changes?
Right.
Or we have to destroy?
Terraform is actually a version control.
Correct.
Yes. For example, what are the resources, or what are the codes in our existing file, okay, that we are using? So we push the file to our cloud provider. Okay. So after applying, we need to change the thing, right? That's the requirement, right?
Yeah.
For example,
Yes.
we accidentally choose the machine type as T2 large or anything like that. So we push that thing, but we need to roll back the deployment, right? So just to go back our open the our configuration file, like the TF file, and make the change. Again, we need to plan and apply that all. So it will create what are our expectations. So Terraform will take that thing and
it will override that the previous.
Right. All right. Oh, yes.
Okay. I got it.
So when it destroys, it will overwrite.
Yes. Yeah. We can.
No. Destroy will not override, I guess. That time it will get deleted. Destroy means.
It's deleted.
So what is overwriting then? Which one is overwriting?
No. My question is, first we'll initialize the workflow, then we'll plan the execution. We'll create the execution plan by Terraform plan. Then we'll apply the changes. Apply. So all of a sudden, if you want to do some changes on the instance and services, so after apply, can you do or not? You told you can do that one. So
which command do you use that one?
No command.
Not
just
okay.
Same procedure, same life cycle.
Same procedure, but we need to change the configuration file.
Code again, you have to configuration code you need to change. I can do it from
and do the life cycle. Go through the life cycle. Like
so you just edit that file and
right.
Okay. But then you have to do init, plan, and apply again.
Not we need to perform the init, only plan and apply, because we already initialize, right, our working directory where we keep the Terraform file.
So every command is like a program that executes, right? So if you change something in the file, then you run Terraform command plan as a command, then it's going to follow whatever in your YAML or configuration file was and apply it, right?
Right.
So that's why it can work that way.
Yes. Mahesh, your requirement is to change something, right? So
Correct.
another requirement, like we need to add something. Okay, we miss something. So what we'll do, we
Yeah.
just to go to the, after applying, we need to add something. Okay, because when we are before applying, we miss that thing. So what we'll do, we just, after applying, we just open the file again and add the new things. Like for example, our requirement is to deploy 3 machines. Okay, but we already deployed 2. So what we'll do, we just to go to the open the file and add the changes like 2 to 3 and again apply. So Terraform will only take the new changes only. Okay, and the existing it will leave. Got it? That is one of the feature of Terraform. Only if Terraform will only, Terraform will check this current state. That's why I told you the plan, because our current state is 2 machines ready, right? That's our current state, and it will check the configuration file again. So coming to the configuration file, we added, we updated 2 to 3, right? Our machine count. So it will execute the newly added thing only. Not, it will create the entire thing again and again.
Okay.
One basic question.
Yes, please.
Sorry, I missed where you said what was the actual advantage of using Terraform? Is it just the higher configuration language that you were talking, or is it a generic thing that we can use for any cloud?
Yes, we can use Terraform in any cloud provider. And why we are,
that I understood, but is it like one file we make and anywhere we can use it? Is that it, or
no.
okay?
For example, we have a configuration file, but we can't use the configuration file in any provider.
Okay.
Because coming to AWS, we need to go different phases to launch EC2 machine, right? So same way
Yes.
coming to Azure, some other way to, they have their own procedure, right? Choosing machine type. In different provider, all the things are different. Like giving name, choosing subnet, IP, all the things are different. So that we need to create code as per the different cloud provider.
So in that case, what is the advantage?
Most probably, if you are joined in any organization, they only choose a single provider. For example, in my case, my organization chooses Azure.
AWS.
Azure. So we need to keep Azure resources or Azure configuration files in this case. So whenever you join a company, you after that we can finalize that. Keeping the codes for the specific cloud provider. But comparing with the codes, okay, some minor changes only we can see with, for example, this one. Okay, first I will show you. We install Terraform here. In our local machine, but our local machine doesn't know which provider we are using. So what we'll do, we need to create a configuration file. A Terraform file, and inside the file we need to specify this is my cloud provider. So for that we need to copy some code, okay, from the official Terraform page. So for the provider, first we need to set the provider in our Terraform. If the provider is AWS or Azure or GCP. So we create a provider.tf file, and inside the file, we choose our provider. So this Terraforms now, our cloud provider is AWS. Then we need to configure the AWS resources code in another file. Similar way, if we are choosing Azure, then we need to provide the Azure provider in this Terraform. Then similar way we can choose the code, okay, like for example, to deploy a EC2 machine or Azure machine, then we need to provide the Azure machine name, then the subnet name, all the things there. Some minor changes are there coming to different cloud provider, because this is HCL. We can easily know when go through the code.
So does it prompt whenever we select the cloud provider? Does it prompt for the next steps as to if I select AWS, it gives certain different prompts, and if I select Azure, it gives the different prompts so that it is self-explanatory?
Yes, yes.
Okay. Then that's an advantage, real advantage. Okay.
Right.
Got it. Thanks.
Amol?
I think I just wanted to add one thing that I'm thinking. A lot of times these open source projects over time slowly and steadily grow very strong. Like 20 years ago, people debated whether Linux would beat Windows, right? But now there is no question that Linux is there, right? So because this is open source, all of the really good engineers can,
Yes,
make
around the
some
world.
code inside their provider to optimize something that's open source, and then still it becomes like a vehicle through which the technology develops more. So that's maybe the more fundamentals are flushed out and evolved better on the open source platform, because in the closed source nobody knows what's happening. So even if there's something very high tech there, those ideas are not shared with the world, so it stagnates. What do you think, Tawfiq? Do you think there's some truth to that? Or
Yes.
I have a question for that related to the Amol question. So I think currently that what we are using open source Terraform, I think this is not up to the business level open source. When you want to go for the real time usage in real companies, it's chargeable, I guess. Correct me if I'm wrong, Tawfiq. Because it will not be available all the features which we are using in the real time project.
Oh, it's like a freemium model, right?
Correct.
Yeah.
Correct. Correct. Another thing for Shilpa question, in the real time in the companies, most 98% of the companies, they will not tell us to go and create services or instances in AWS manually. Everything they will tell us to go create through code only, through configuration code. So because if they wanted to change anything changes, you directly go to the Terraform, do some changes in it and apply it. So what I heard from my colleagues and all, so most of 98% of the companies, they will follow automation process in the creation of services, creation of instances, handling Lambda for everything.
Because coming to production, we need to deploy, we need to configure a lot of things.
Yes.
So it will, time is one of the concern there. So
Correct.
if you go manually, it will take more time, right?
Correct.
So because our clients there, our output, we need to show our output. So it will take time, then it will affect our cost. All the things are there. That's why most of the organizations choose automation.
Yes, that is advantage, Shilpa.
Okay.
Quickly we can deploy our infrastructure and quickly we can destroy and adding our resources.
The automation is the advantage of Terraform, is what Mahesh just said, right?
Correct.
Right.
Okay.
Automation and maybe level of it is easier here rather than going to AWS and configuring things. And would you be sharing a sample with us?
Sample
maybe
what?
lab sample
Still is not started, I guess.
Okay. Okay. Yeah. Proceed.
Yeah, we can start the lab.
Sure.
My screen is visible, right?
Yes.
Okay. So then from scratch. Okay, I'm showing from scratch. So my requirement is to install Terraform and deploy a virtual machine using Terraform. That's a simple task, okay, for today's lab. So for that, I'm choosing my cloud provider as AWS. I have a AWS account. It's an active account. So, and I need one local machine. Okay. In my case, I am not using my local machine. I mean, my laptop as my local machine. I will take one machine from the AWS account. Okay. For a local machine. So that I first go to the.
You
Your
have a
voice is
bad
coming to the break.
connection, Taufik. I think you need to place the mobile somewhere where you get a signal. Last time you did that.
That's what the Terraform file says. Place the mobile in the right place.
Yeah. You are not audible.
Now it's clear, right? Yeah.
No, not at all. You were not clear. Can you repeat?
Now it's stable.
If you speak, we get to know.
I can hear him.
What about others like Mahesh?
Yeah, I can
Yeah,
hear
now
you,
it is fine.
Okay.
but sometime in between your voice will
Yeah,
get break.
now I place my phone better place.
Okay.
Okay.
I think it will work now.
So coming to lab, okay, this is my local machine. This is my local machine. And this is the AWS account. Okay. So first we need to create a connectivity from our local machine to service account. So what we'll do?
Creation of CLI.
Yes. So that first we need to create a local machine. Okay. My laptop have some privilege issue. That's why I didn't perform that thing in my local laptop. So that what will I do? I just launch one machine and keep it as my local machine. So I'm going with the Amazon Linux. So Tejaswini there, right?
Oh, yes.
So Tejaswini, this is a lab for launching one virtual machine in AWS account. Okay. So,
Okay.
so first, this is the page. Okay. Our landing page. So here we can see a launch instance there. So click that one. This is a manual way. Okay.
Okay.
So we need to give some name. So I'm giving local machine. Then we need to choose. This is a kind of, we are going to purchase one machine. Okay. Consider like that. So this is virtually we buying one machine. Okay. So we need to provide one name and we need to choose a operating system for our machine, right? Like Windows 8, Windows 7, like that. So here I am choosing Amazon Linux. This is a Linux kernel customized by Amazon. So I'm choosing this Linux operating system. There are a lot of other operating systems we can see here. Then we need to specify the machine type. Okay, this is a configuration part, like the CPU, how many CPU we need or we want, and memory, RAM, all the things we can choose here. So now I am going with the free tier. Then we need to create one key pair. Okay, key pair is nothing. It's a encrypted code to access our machine remotely. For example, now I am going to launch this machine. Okay. After that, I need to authenticate or I need to log into the machine using the key pair. Okay. So I have some key pair. So I use the existing key pair here. Then we have a network part. I didn't go deep this part because I already covered that thing. I will share the recordings of networking, all the things.
Okay.
Then this will be fine. And I'm just enabling the port. Okay. I hope you know the ports, the logical ports. No idea, right?
No.
Yeah. I'll share the recordings. Now you can see we successfully launched the machine manually.
Okay.
See, the local machine is ready.
Yep.
Yeah, this is running. So now I am going to quickly connect this machine. So select the machine, and here we can see a connect option. So click connect, and here we can see connect. Click again. So now we go to our machine. Okay, this is a Amazon Linux machine. Okay, so our local machine is ready. Amazon Linux machine is ready. So we need to create a connection between this machine.
Yeah, Taufik, I have a
AWS.
question.
Yes.
In real time, are we going to create a local machine AWS, or it's altogether the system is they're giving by even the company we're using that one? How?
No. For example, if you join a company, they will provide the laptop, right? New one.
Correct.
So we need to install.
Directly, I can go and install on Google Terraform.
Yes.
Through Visual Studio, add Visual
Yes,
Studio,
yes,
and I can
yes,
download
yes,
CLI.
yes.
We're not going to do creating anything in the AWS, right?
That's, for example, as a DevOps engineer, we have the cloud admin. We will get the admin privilege.
Okay.
So that we can go to the dashboard. Graphical way we can access, or like command line. Both are there actually.
Yeah, that I know. So my question is, so in real time, a company will give a laptop, which will be having the Linux or Windows, whatever. So we can directly go to the Google and download the Terraform, and through Visual Studio, we can connect to the Terraform.
Right.
So then we can download the CLI and connect to the AWS account.
Right.
Okay. So here
Yes.
now we are creating a virtual machine, Linux virtual machine in AWS itself. In real time also we are doing the same thing, or how it will
In our
be
local machine.
in our local machine?
That's why I called
Okay.
a local, like laptop or the desktop.
Okay.
And in real scenario, we didn't download this from and install from, using Google or anything, because some security issues there. So it's corporate, right? So they will provide the files, and their engineer, like some engineers will assist, or they will take our machine and they will install these things.
Okay. Yeah, that we need to raise a ticket for that to install the Terraform. And
Yes.
correct. Okay. That I know. Thank you.
Okay. So yeah, now our machine is ready, and we need to connect with our AWS account. And after that, we will install Terraform in our local machine. Okay. So first we need to create a connectivity between our local machine to AWS account, so that we can say we can do anything from this local machine, and we can deploy our resources via command line to AWS account. So that we need to create a user. So we just to go to IAM. Here we can see left side user group roles policy. So now I am going to create a user. Okay. That user for the local machine. So click user. And here we can see the user dashboard. So here we can see a create user. So click create user and give it a name. Terraform user. Then here we can see provide a user access to AWS console. But if you tick this thing, then the user can access AWS console. But I didn't tick that thing, because this user only work with the command line. Okay. If the requirement, then we can choose that thing. Then here we give the permission to the user. Okay. So we can choose here there is two users, user group there. One is administrator and EC2 tester. So I'm going to giving administrator access to the user. Okay. So click the administrator access. So this is actually a group. Okay. Inside the group, we can see there is some attached policies. See, one more. For the administrative group, some other policies are there. But my concern is give the administrator privilege. Okay, that's all. So in this case, I attach some other policies to the administrator group. So that is AWS EKS and S3 full access. And one more thing is like administrative privilege. That's the thing. So I'm going with the next. Create user. So the user is created. Okay. So here we can see, yes, you can see here that the group, okay, inside the group, there are three policies are attached. That's why these two things are here, like AWS S3 full access and EKS access. But our need is like AWS and administrator access is fine. So when you create, you just go to the, you create users and create user, then give it a name, then choose the policy administrator access. That would be fine. Okay, so now we successfully created a user and attached policy for the user, that is administrative access. Then then we need to authenticate, okay, using AWS CLI. So AWS CLI is a tool to interact with the command line tool. Okay, it will give a AWS command line tool so that we can authenticate with our machine to AWS Cloud Provider. So how to install AWS CLI? We can choose from, just Google it, AWS CLI. CLI install, download. So here we can download from official AWS documentation. See, so we can choose corresponding machine type. So in this case, we can go with the Linux. So go through like this, copy the command and paste it in our machine. So it will download the AWS CLI. So now I choose a machine from AWS. So it's pre-installed here. Like we can check that AWS. After installing AWS CLI, how we can authenticate using AWS configure command or AWS configure. Yes, AWS CLI is actually installed in this machine. Okay. So that it will shows like AWS access key ID. So we need to provide the details. Okay. So where we will get the AWS access key ID? We already created a user, right? So this is a user. So now I am in the user page. So here we can see permission, group, tag, security credential, all the things. So go to the security credential, okay, of this Terraform user. Then here we can see access key. Yeah, see access key. So as of now, we didn't create an access key for this specific user. So now I am going to create an access key. So create access key. And we need to choose which use case, okay? In my case, only CLI, okay? I mean, these users perform command line interface. So choose the one and next. We can link this thing, create access key. So access key is created. And this is the access key for our user. And this is a secret key for our user. So now we are providing the access key, okay, to here. So copy the access key, paste here, hit enter. Now it asks for secret key. So this is our secret key, okay. So this is a secret key. Copy the secret key and paste it here. Hit enter. Then we need to provide the default region name. So in my case, US East North Virginia. Okay, US East 1 is my default region. So I am providing that US East 1. Hit enter. Then this is default output format. Okay, this is the which format that we will get output. Okay, we can leave it as enter, or else we can type like a JSON format or any format there. So after that, it will shows like that format. So now we can say we successfully connect with our AWS account using the access key and secret key. Got it. So the next thing is this connection is done. Then we need to install Terraform. So that we can go with official documentation of install Terraform. So that just Terraform. Install Terraform and click the hashicorp developer. So I'm going with that. Then here we can see manual installation there, Brew, Mac, Chocolate Tree, Windows, Linux. In our case, we can choose Linux. And coming to Linux, Ubuntu there, CentOS, Fedora. We are using, I am using Amazon Linux, right? As local machine. So that I'm choosing Amazon Linux. Before that, I will check Terraform version. Terraform. See, Terraform is not here. So we can install using the commands. Paste. Adding repo. Then install Terraform. Done. Terraform version. See, version 1.8.5 on Amazon Linux. So this way we install Terraform. So the installation part is done. Then now we are going to provide the which provider that we are using. We are giving the details to the Terraform in the local machine. So we need to create some Terraform file. Okay. First we need to provide which provider that we are using. So we need to create a file called provider.tf. In our local machine. So inside the provider.tf, we will provide which cloud provider that we are using. Okay. So the Terraform the Terraform running in our local machine, right? So the Terraform knows our cloud provider is AWS or Azure or GCP. So now I'm going to create one file sudo nano provider .pf. Okay, so we can check the provider file from official document. See, this is a Terraform. We can see, we can easily find the Terraform configuration file and all the things in official Terraform page. So I'm just searching AWS provider Terraform. So go to the first website like registry.terraform.io. So click the one. So this is for AWS provider. Okay. So here we can see the sample code and all the things. Our requirement is getting the provider file. Okay. So here you can see use provider. So click that one. So this is the provider file. Copy.
Can you explain that file once? Because somehow I feel that this is not just to define which provider, because already the user is in AWS. So
Yes,
what
yes.
is the purpose of again defining?
So this is a configuration file. Okay. So this is a Terraform file and required provider. Then we need to provide the AWS. Here we providing the AWS as our provider. Then AWS. And this is, in this case, we include the source and version of hashicorp AWS. So we can remove these things, no problem. We only provide, giving the detail of our provider, like provider AWS, that would be fine. But this is, we copied from the official website. That's why we are including all the commands here. Got it?
No, actually, I didn't still understand the actual purpose of this. We are creating the Terraform user, the user that we got connected here. That user is created through AWS, right?
You mean Terraform user, right?
Yeah.
So you leave the user, okay? The user creation is only for the connectivity from our local to AWS account. We already established that connection with using the Terraform user. Now we are, after that we install the Terraform application.
Using the same user, the key that we created, right? On AWS. Sorry, I'm failing to understand the actual purpose of defining the AWS provider here.
Yes. Yes, we successfully first what we'll do, we created a connectivity from our local machine to AWS account using using AWS CLI, right?
Yeah.
We installed AWS CLI. In our case, we didn't install AWS CLI because it's pre-installed in our Amazon machine. After that, we need to authenticate with the user, right? So we create a user in AWS and give the permission to administrator, and we provide the access key and secret key in our local machine so that the user interact with the AWS account. That's fine. That's the first part. Okay. Then leave the part. Okay. There is no communication between the first part and second part. Second part is, our requirement is to install Terraform in our local machine. So we successfully install Terraform in our local machine. After that, we need to work on Terraform, right? So what we'll do, we need to talk with the Terraform. My provider is AWS. That's our requirement. So how we...
So the user login that you logged in on the command line, you're saying that's not relevant to the Terraform installation?
Yes. That's a second part. Leave that part. Okay. This is only for the communication between the local machine and our cloud provider. So we create a username Terraform user. Okay. Oh, I think the Terraform user confused you, right?
No, it did not confuse me in that way.
Yeah.
I thought even the Terraform installation happened through the same access key that you logged into the command line prompt.
Tawfiq, actually, if possible, if tomorrow, can you use the other laptop where you can access from the local laptop to through using Visual Studio and downloading Terraform from the Google and accessing the AWS? Better she can understand.
Mhm.
Correct me if I'm wrong, Shilpa. Actually, he created one machine in AWS just because he's not using his personal laptop. One machine is created, and he wants to connect that machine, and the machine wants to understand which provider it is. Either it is Azure or it is a AWS. Now he's taking that AWS
Yeah,
and creating
I got it now. Yeah.
got it right. For that, he's creating one file called provider.tf. In Terraform, always file extension will be tf. So for creation of one file, we need one configuration code. I just copied from the Google.
So
Here this one.
it is unique for different cloud providers.
Right.
Yes,
Your
correct. Instead of AWS, something Azure will come. Something will come.
GCP, then here the provider is GCP.
GCP will come, and version will get changed. That's it.
Got it, Shilpa?
Yeah. Got it. Thank you.
And this configuration file is only, providing that our provider is cloud AWS. Okay. So save and exit. Let's see in our local working directory, you can see one configuration file is there, that is provider.tf. So the next thing is we need to create, now we are going to create, our requirement is to create a virtual machine. Okay, consider our requirement is to create a virtual machine using Terraform. So we have the AWS here, our local machine here, Terraform successfully installed, and we are going to create a configuration file or a Terraform file, and inside the file we define our requirement. Our requirement is install or launch one EC2 instance in here, okay, in AWS. So that we need to create another file, and we can give the name as resource. Okay, sudo nano resource dot tf. So now we are going to create a file resource.tf, and inside the resource.tf file, we need to include the code. The infrastructure as code. Okay. So we can quickly EC2 instance Terraform. So here we can see official Terraform registry. We can see the resource types. Okay, like sample code and thing. So this scenario we can copy.
Tawfiq, I have a request here. Instead of using Google, can you go ahead and check it in the ChatGPT or Copilot just for code for creation resources in Terraform like that? So it will not,
Yes, we can. But today I will show you quickly create a mission. Okay, EC2. So this would be fine. This small snippet. Just to copy.
That will.
Yeah.
That will create that will give you exact code which we need to create a resource. Here, the multiple code which will lead to confusion.
I only copy this one. I will show you. But yeah. Okay. So this is the small, very small code snippet, okay, for deploying a EC2 machine. So first resources, see resources. Then this is a common keyword that we use in Terraform, okay, resource. So after resource, this is resource type. See, AWS instance is a resource type. Then one more thing after resource, that is resource name. Here, web is the resource name. So when we define a resource, we need to provide the resource type and the resource name. Okay. So here we are going to deploy a EC2 machine. So that is our resource. So resource, then the type is AWS instance, then the name. Okay, web. So we can change the name as VM1. Okay, VM1. Then again, open a curly base for the configuration of the resource. So we need to provide the AMI. Now we are going to launch a mission. Okay. So how we launch a mission manually, we need to give the name, then choose the like machine, I mean OS, operating system. When we choosing the operating system, you can see the IDs. Just to go to the manual way. So here we need to provide the name. Okay. This is a manual way of deploying machine. Then here we need to choose the operating system. So by automating this thing, we need to provide all the things, right? So for example, I'm going to choose Ubuntu or Mac or Linux. Here you can see there is a AMI ID. Okay. So I'm choosing Mac. So this is the AMI ID for Mac. So I'm choosing Amazon Linux. So I'm choosing Amazon Linux. So the AMI ID will change, right? So each operating system, they have their own AMI ID. Okay. So how we choose the required operating system using AMI ID, okay, in Terraform. So copy the AMI ID. So I'm going to deploy Amazon Linux, okay. So go back. Here we need to change the AMI ID. Using right, copy. Paste. Okay. Then the instance type. My instance type T3 micro, that would be fine, okay. Then tag name. We can leave the tag name or we can choose the tag name. I mean, provide the tag name as production. Okay. This would be display in our machine name as name. This would be fine. Okay. Then we can copy, sorry, read and exit. So here you can see two files are there. Okay. Now I'm just changing my directory. Okay. Like CD. Now I'm creating one directory. This is for a test purpose. Okay. I will show you how the Terraform init will working. So I'm going to test. We'll check the Terraform init. So I'm going with the Terraform command. Okay. So I'm going to start with the first lifecycle Terraform
init. See, Terraform init initialized in an empty directory. The directory has no Terraform configuration file. You may begin working with the Terraform immediately by creating Terraform configuration file. Yes, Amar.
Which directory did it get created in? Inside the root, it is created some Terraform directory?
No, the current working directory where we're working.
Oh, it's current working directory, which is for this one, it will be the user home, maybe, right?
Yes. So now
So if you do PWD, what will come?
See, now I am in home EC2 user
Home
test
EC2
directory.
test.
Okay. I created
Okay.
one for how the Terraform init work. Now I am going back to EC2 user where my configuration file belongs. Okay. Then I will try once again the init command so you can see how that initializing work. Okay. So cd
Okay.
ls. See now my configuration file here. Okay. Like provider.tf and resource.tf. So try the command again. See now it's initializing the backend.
If we have multiple files in the directory, then it will initiate everything.
No. Commonly, we are working with a single directory and keep all the configuration file in one directory. Or in different projects, then we will create different, directory and keep the file there.
Directories.
Yes. So now you can see Terraform has been successfully initiated. So now we can go with the next command, Terraform plan. So, okay. So it will show our configuration or what are the things that we are going to perform. All the things we will see in a Terraform plan command. Okay. Terraform plan. So we can review our configuration here. So see, here we can see, yes, Terraform user select, create, yes, Terraform perform the following actions. Okay. So this is the final, before the final stage. Okay. So the next stage is we can apply what are the things listed here. Okay. So if anything we can review or add or remove something, so we can go back and edit our file and apply. Or else if these plans is good, then we can move forward. Okay. So here we can see our T2 micro listed here, password false, all seen here. Non after apply means all going with the default. Okay. We provide the Amazon Linux image here. Then only 3, 4 things we include in our Terraform file. Result.tf that will listed here. Okay. And here we can see plan 1 to add. So now we are going to apply the plan 1. Terraform apply. And we need to, there's a pop-up for like moving forward or not, approve or not. Type yes to approve.
Did you have to put 1 instead of yes?
Yes, to approve. Only yes will accept to approve. So we will get a error like error EC2 instance operation error, run instance HTTP for API error, VPC ID not specified, not default VPC for this user. Group name is only supported for EC2 Classic. That is V1. Okay, I think we miss the security group and subnet for the machine. Okay, so that we can include that thing in the resource.tf file. Just open sudo source.tf. So we can add that thing. Security. So we need to copy the security group. Okay. Go to instance. So here we can go with our local machine security group, or copy any security group. Okay. Any valid security group. So this is a security group, one of the security group in my AWS account. So I just copy the security group ID. If we have any specific security group, then we can choose that security group ID. Okay. So just I'm copying this one. Paste here. Okay. And we need to provide the subnet ID. So I'm going with the VPC and subnet. I'm just copying one of the subnet ID. So I will go with the GS public. Okay. So GS public, copy the subnet ID. Paste it. Now I am checking with save and exit. I am going to plan again. Okay. Security group ID. Some error in code. If any error in code, then we will get the unsupported argument or like that.
Is that square bracket part of the
Can you-
syntax?
Can you remove that bracket?
Hmm?
Can you remove the square bracket for the security group ID?
Yeah,
I
that was
think we
that's
need to
what I was
specify.
asking.
I missed the VPC in front of the security. That would be the reason. Check again. Security group ID.
Can you do PWD again to make sure you're in the right directory?
No, same directory. I think remove the yes. Okay. Try it again. Some small changes will make the error actually. I think now it's sorted out. See,
Yes.
now it's sorted out, and you can see the subnet ID is here listed here, and security group also. See. So now we can successfully plant. Then we can go with the apply. Yes. See, AWS instance VM creating. So same time we can go to our dashboard and check the machine is creating or not. See the production listed here. This is a machine we are created using Terraform. The machine is creating, still creating, creation completed, 12 seconds. It will take only 12 seconds to create a machine. Apply completed, resource one added. Got it. All of you.
Yeah.
Yes.
Any doubt? Anyone have any doubt? So this is the way we launching a single EC2 machine using
No,
Terraform.
it's fine.
All good, right?
Can I just recap what the Shilpa had asked? So initially you created a machine that through the it was an Amazon Linux machine on your laptop, and then it was talking to the Amazon cloud machines remotely. You gave a password, you gave like the key and a public key so that it would authenticate and connect.
Before that, I
right?
created a user for the authentication. My question is like, for example, if you joined in an organization, okay, as a developer or a developer engineer or admin or cloud admin, anything. So there is a admin or root admin there for managing the AWS account. So they will give the username and credential, right, to access the cloud platform provider. So similar way, I am creating a user, Terraform user, and I mean creating the access key and private key so that I can log in with my credential to my AWS account. That's a simple. Yes.
Right.
For
So,
example,
but
yeah.
then you had to tell it that I am connecting to a AWS. That's why, because it doesn't necessarily know whether you're connecting to AWS or not. Even though it's using the Amazon command line interface, it doesn't know. It's just the remote machine is talking to. So that's where Shilpa had asked you, like, why do I need to clarify again? But you have to, because it doesn't know it's AWS. Is that correct?
Yes.
And it could have been Azure or anything there.
Right,
because the virtual machine on your laptop was an AWS virtual machine, but that doesn't mean it cannot talk to a Azure virtual machine.
Yeah,
You put
it can talk. For example, this is a machine, right?
Yeah.
So what will we do is, this is the machine. Okay, so we need to install Azure CLI in this machine. Got it. Now we install AWS CLI in this machine. Okay. For example, we can use to automate Azure infrastructure from this machine. We need to install Azure CLI. Then we need to create a user in Azure account and give the credential. Then we need to provide that thing here so that we can say from this machine to Azure account, there is a connection. And the policies define the privilege like admin or any other thing. Then we can install Terraform here and pushing the code from here to there. And provide, give the Azure content in our Terraform file. Got it.
Right. So you could do. So this Amazon machine could connect to a Azure CLI through Azure CLI.
Yes.
But just because you had the AWS CLI here does not mean that Terraform knows that it's connecting to AWS. So you have to specify that.
That I told you, that is two part actually. First part is make a connection between this machine to AWS account. That's the first part. Then installation of Terraform. That is not, connect with the first part because both are different. Got it.
Yeah. It's like
So
all good software engineering is very modular, right? It's each piece is has to be defined and does its specific thing and it's tested. That's
yes,
why it's evolved to be like that.
right. So in our case, we successfully installed one machine. Okay. So my requirement is I need to install one more machine, and that machine would be Ubuntu version, not Amazon Linux. What will you do? Any idea? Anyone?
Just you
Can
need
you
By
repeat the
to
question?
automation.
Can
Uh,
you repeat the question?
I have one more requirement to deploy. I mean, launch one Ubuntu machine using the same way via automation. What will you do?
yes, or you have to copy the AMID from Ubuntu, and
Okay.
in the resource file you need to add multiple instances need to be created there.
So I just copy this AMI, right?
Yes.
Right. So what we'll do? Sudo nano resource dot f. Okay, open the file, and what will you do? Just
Add one more.
copy. And paste. Not bad. Okay, then change. Resource is equal to, I mean, resource type, that is a the name would be VM2. We can change to 2. Then AMI would be changed, right? So remove the AMI because this AMI is pointing to only Amazon Linux machine. Our requirement is to deploy Ubuntu. So copy the Ubuntu AMI, then paste it here.
Change the name into a database or something.
Yes, tag, we can change the tab as production to pre-prod. Pre-prod. Save and exit. Plan again.
Not in it.
No need, because we already init with our local directory.
Init
Okay,
made the directory there. So now it's already the
Okay.
directory is initialized.
Okay.
Apply. See, it's creating. Just go to our EC2 console. See, pre-prod is running. How fast, right? So now I am just going to delete one thing, okay? Or else we can deploy all the things, right? Yeah. So now I am going to destroy the machine that
Yes.
we created, okay? That production and pre-prod. So what we'll do? Terraform.
Destroy.
Maybe destroy only one and see.
Yeah, both will destroy because in our Terraform resource, we mentioned both files, right? Both machine configuration.
Can we give a Terraform destroy a particular name of the instance and destroy?
Yes. You can use flag. See, both
Okay.
destroy. You can see. Give me a second. See, instant state equal to terminated. See, production is study. Is under deletion. See, pre-pod is terminated. Destroy completed. Resource 2 destroyed. Got it. All of you.
Yeah.
Yep.
So tomorrow we can build a data center using Terraform, like from VPC, security group, subnet, inter gateway, all the things we can build from, using Terraform, and we can include a configuration, launching of machine. Then we can include application deployment too. Okay. So what are things included in tomorrow section means creation of VPC and the component, VPC components, like in the gateway, subnet, route table, routings, routing role, all the things. After that, launching machines, then installing web servers, then exposing application. Got it? All of you.
Okay. Yeah.
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 Can you show it in the through VS?
Visual Studio Code.
Yeah.
For Visual Studio Code, I can't authenticate today. I'll show you some error to my local machine. This is a local machine IP. Okay. This machine. This machine IP 115, not 115. Check. Okay, anyway, I will check. Okay.
Okay.
Yeah. So, anyone have any doubt regarding today's section?
No.
All are good, right? Shilpa?
Yeah. Regarding the keywords that you have used, is there a list somewhere that we can go through, or always
No,
we
today,
Google it and
yes.
get the syntax?
Today, Shilpa, today I only included small snippet, right, for AWS. So coming to
Yeah.
tomorrow section, I will explain all the scenarios, like step by step, VPC, and all the resources, okay, that we include in the tomorrow section. So you will get idea how we mention all
Okay.
the things like that. Yeah. Okay. Then time is too late, I think. If all are good, then we can wind up, right?
Okay. Have a good night,
Yes.
everybody.
Yeah,
Good morning,
sure.
Tawfiq sir. Bye.
Good
Yeah.
night.
Good night, all.
Bye.
Yes. Tejaswini, you are there, right?
Yes.
Yeah. Can discuss. All of us can leave. Okay. Bye all.
Bye.
Bye.
Bye-bye.
Is it okay if I stay on?
Shilpa?
Yeah.
Yeah,
Because
you
I
can
too
stay.
have,
Yeah, no problem. Yeah.